Part B.2, display math symbols using a special tool called MathJax. Yeah. Because our project, we need to manage math questions. So we need to display all the complicated, various different math symbols in a good way. Yeah. So we need to consider that. Here, I want to talk about what is the best way to display math symbols. Yeah. Here, I want to compare two ways. One, HTML math symbols. We know this is a web application. We display all our content on web pages. If HTML supports math symbols well, then we do not need to use other tools, right? We just use the HTML way to display the same math symbols directly. Yeah. So here, let me show you a few HTML math symbols. The first one in this way. Okay. Here you can see in HTML, it supports many different math symbols. Here, the format we used here, you can see that's we call HTML entities. HTML entity. So you can see, start with ampersand, then the entity name, then semicolon, ends with semicolon. Okay? Yeah. In this way, that is the format of HTML entity. So the web browser, so they can display those special symbols when they see entities expressions. Yeah. But also here we use names, but another way we can use code. Yeah. The code way, it is much harder to memorize code way. Who can memorize these numbers, right? Very hard. But these symbols, yeah, because we know their meaning, right? So it is much easier to use the name way, entity name way. Yeah. All right. So another image about the more HTML, more math symbols in HTML entities. Yeah. Although there are more, but here I think that's enough. So you get idea. Yeah. How do we use HTML internal support for math symbols? Then the question, why? We need to consider some other external math tools for math symbols. Yeah, the reason is very simple. So the first, HTML entity way, too limited. So what do you mean too limited? That is, it can only display a small portion of math symbols. Yeah. So only a small, very small portion. Okay. Small portion of math symbols. Yeah. Sorry. And we have a large number of math symbols. So you can imagine the number of different math symbols. Here we are talking about all the possible math symbols. Not just what we used in algebra, trigonometry, calculus, linear algebra, Here we are talking about all possible math symbols. That's a big number. So you can imagine probably thousands of different math symbols, that the whole world we need to use. So that large number, the HTML support only, a tiny fraction. A tiny fraction. Yeah. So then, for that reason, a much stronger math symbol toolbox needs to be used. Okay, yeah. So that is the reason. Here we use LaTeX math symbols. So this is a special math typeset language. Yeah, so it's called a math typeset language. All right, yeah. First, it is not a programming language. Okay, programming language has logic features, right? You can do logical things. LaTeX, you cannot. LaTeX, you cannot do logical things. Yeah. Only display special math symbols. That's it. The only purpose using LaTeX math symbols. Yeah. All right, so that's one. Yeah, typeset. And another thing, brief history, a little bit about this LaTeX. Brief history. Yeah. Its initial, the first version called a TeX. T-E-X. Yeah. The inventor was a Stanford mathematician, Knuth, very famous mathematician in Stanford, professor. Now, he created this TeX typeset language many years ago. So probably 40, 50 years ago. So long time, yeah, probably 40, 50, in that number of years ago. Okay, yeah, called a TeX. The pronunciation, do not pronounce TeX. Do not pronounce x. TeX. That's it. TeX. Yeah, because the designer wants to make that pronunciation. Okay, so we have to follow the creator's way. All right, yeah, and he even write a character, capital T, capital X, lower e. He even used this way for his language. Yeah, it was very successful. Yeah, so that all the mathematicians, because mathematicians, they want to use high quality math typeset language. Different from in Microsoft Office, there is also support, right? So math symbol support. Yeah. So in Office, yeah, we can type math formulas using Office. Yeah. But the problem of that is, first, the representation, the formula rely on MS Office. The formulas rely on MS Office. So it is not good for web pages. It's not a text string. Formula not so in MS Office. Yeah. Math formulas are not in strings format. Yeah. So the representation binary format, internal representation format, binary format, not a string text format. That's not friendly for web pages. When we display content in web pages, we want the text format, not binary format. So that's why the MS Office way, not good for web pages. Yeah. But this TeX language string format. Any math formula can be represented in certain special strings using special commands. Those commands defined in that tech language, original tech language. But why does LaTeX? All right. Because the original tech, although it was very powerful, but still a lot of shortcomings. So a lot of features not very convenient. Okay, yeah. So then later, there is another professor. Yeah. First, he really liked this tech typesetting language. But second, he had a very strong feel that this language should be greatly improved. Yeah. He had a lot of good ideas to improve this language. Yeah. And also, he had the skills. He was very familiar with the programming language. He's a good programmer, right? So he can do it. Yeah. So then he developed an improved version, using his name, LA. So that's the, some letters from his name. Yeah. So LaTeX. Yeah. He created a newer version called LaTeX. Yeah. So right now, everyone uses LaTeX instead of the old style tech. Yeah. So almost nobody uses the old style tech. Yeah. But this LaTeX, the most popular, the current math typesetting language. Yeah. All right. So that is the brief history about math symbols. Next, tool, package, to display, to translate. Remember, so each formula represented in a string. In order to translate the string into an image, the formula will be displayed as an image. Okay, yeah. Here, let me describe. Okay, yeah. So, a math formula. So we need to type a math formula. Okay, yeah. Then we use the commands. The command. Most mathematicians, they can memorize some commonly used commands. But think about the thousands of different commands. Nobody can memorize, but they can search. Book. Yeah. So there is a thick book. Talk about the features in LaTeX. Yeah. Or just online search. Yeah. Whenever we need to use some command, we just type online, so we find examples, then we just use those commands. Yeah. So formulas represented in a string using the commands. Okay. Then, in order to display, it needs to be translated into an image. Okay. Yeah. This translation, we need a special tool to do it. That special tool, you can imagine, it's not easy, very complicated. You can think about translate thousands of different symbols in many different ways. How complicated it could be. You can never imagine how complicated it could be. Yeah. But anyway, one organization did it and make it available online free. That's a great thing. So for us, we just use that package. So let me talk about MathJax JavaScript package. So this package developed in JavaScript. So you can imagine how useful is this JavaScript. So JavaScript does the translation, the code translation. Yeah. But it definitely use HTML, CSS, yeah, because when you formulate a formula, we know some formulas could be very complicated. So there is some nice arrangement of different symbols, different locations. So you need to use CSS to put in different positions, right? Yeah. And how to manipulate different parts, JavaScript. All right, yeah. So basically, that package uses these basic web technologies to render the complicated math symbols. Okay. All right, so here, let me introduce how to use this package. I want to talk about two different ways to use this package. The first way, download the whole JS package to local server. Yeah. The first way, because it's available, it's free. Yeah. You know, the great thing is it's free for everybody. Okay. Yeah, so nice. Yeah. So you can download. Yeah. So you go to MathJax website, so you can download the most recent version. Yeah. But this package is huge. It's huge. It's big. Okay. So I used to download, you know, several years ago, yeah, to my local machine, so I can use in my local server. Yeah. At that time, so I got approximately greater or equal to 300 megabytes. How about that? One package, more than 300 megabytes. All different images, because the formula need to be represented in image components. For all those different image components stored in the package. So you can imagine how big. So then JavaScript code manipulate those images. Okay. Yes. Yeah. All right. You can see if in our web applications everywhere, if we just use this package, if we need to download, you can imagine your web application could be big. It's so big. It's not easy to copy here, there, different places. Although you can upload, right, to your server, yeah, but still not quite convenient. Yeah. Anyway, but this is one of the options you can use. Yeah. If you use this way, just the traditional way, suppose you already download to your local server, you just use this standard way, script, element, tag, so then location of this, yeah. So you download, suppose this folder, the whole package you put it in MathJax folder in your web application, for example, okay, yeah. Then there is a MathJax.js file. So this is the main file. So this file can call other files in this package, you know, yeah. So you just do put this element in your web page. So you can use it. Okay, all right. But there is another way, sometimes pretty convenient. So I like to introduce that way. For our class, we will use the second way because we don't want to download that big package on our local machine. Yeah, so we want us, you know, convenient way. The second way is use CDN link. So what's that CDN link? So that is, some of you know it. Content, delivery, network. CDN link. Yeah. So that's this. You put this link, connect to that, you know, MathJax server, their server, remote server. So not your own local server. So MathJax server. Yeah. Every time when you need to, do translation processing, you just call remote MathJax server to run and send you the translated result. Yeah. Although it takes some time, but pretty convenient. The good thing is you do not need to download that big package on your local machine. Yeah. So for us, when we develop any web application using math symbols, we only need to put this small paragraph in our web pages we can use. So convenient. Okay, all right. Then after you choose one of the two ways in your web pages, then the third thing you need to do, configuration. You do a small configuration. Okay, the configuration is standard in this, so I put it here. Okay, all right. Here, let me explain this part a little bit. Yeah. Because when we use LaTeX, now, how do we display math formulas? Yeah. Because when we make a math question, we need to use our sentences. In our sentences, we embed some math formulas. So that's the typical way we use math formulas. Yeah. So you need to think about, we embed math formulas in our sentences. Yeah. So you need to create a special math environment when you display math formulas. So that special environment, there are two cases. The first one called the inline case. Inline case, yeah. So you have a natural sentence. So somewhere in the middle, you put a math formula. That's the inline way. Another way is called a display way. All right, yeah. Display way. Yeah. Display way, so it's not inline, right? So you start a new paragraph. Yeah. Sometimes you need to display a big formula. So you put it in the center, your big formula in the center. Okay? No text around it. Okay? So this part, you make the space to display a whole big formula. So that's the display mode. Okay? So there are only these two modes in LaTeX. Yeah. All right. For the inline way, you need special symbols to tell the translator how to find the math formula. So in LaTeX, the standard symbol is a pair of $sign. Your formula start with $sign, ends with $sign. Okay, so that's the standard way in LaTeX. Yeah, all right. But in web pages, if you use this way, not very convenient. Why? Yeah, because we know in our math questions, many times we need to use $sign for that dollar symbols. Okay, yeah, we know. Yeah, so we don't want to escape it. Yeah, in LaTeX, when you use dollar symbol, you can escape it. Use \$ so you escape the $sign. All right. Although in web pages we can do that, but not convenient, right? So it's not, for stream processing, it may not be very convenient, all right? Yeah. So for that reason, we just want to replace, we use \, open parenthesis, for the starting symbol for math formula, inline math formula, all right? So then you put your formula. End of math formula, \, close parenthesis, end of the inline math formula. So when you use that, much easier to provide, formula processing. So you can think about if you need to do formula processing, which way easier? This way easier or that way easier, right? So you can imagine, so definitely this way easier, right? Yeah. So that's why in our configuration, we replace that. Only for the inline part. Yeah. For the display part, there is also a special symbol. In LaTeX, the special symbol is backslash open square bracket, close backslash close square bracket. In that one, there is no confusion, right? So we can use the original way. So we do not need to change to other different symbols. So yeah, all right. So that's the background information I like to give you. Yeah, although pretty brief, yeah, but hopefully you, with this background, so you can feel better when you use this MathJax mathematics typesetting language. Okay, yeah. All right. All right, so let me stop B.2 here.